This is EJL Instructs, episode number 3. What's in a Blazor Desktop project? What projects are in the solution? What files are in each project? And how do you write platform-specific code? I'm Alon Lipton. Let's jump right in. To get started, I ran the command .NET new Maui Blazor and specified a project name. Now that we've created the new solution, we can open it up in Visual Studio and see what's inside. The first thing you might notice is that there are two different projects in the solution. Maui Blazor Demo and Maui Blazor Demo.winui. Why two? Well, let's open up the project files by double-clicking on them and see what's inside. The first thing we can see here is the specification of the target frameworks. This tells you which platforms this project is targeting. The Maui Blazor Demo project is targeting iOS, Android, and Mac Catalyst. And when we open up the WinUI project by double-clicking on it, we see that it's targeting Windows. Well, why two project? This is a current limitation of how we're able to ship .NET MAUI with Blazor, and we hope to resolve that in the future by combining all of the projects into one, which would involve taking this target framework and adding it to the list of supported target frameworks in this project. We hope to fix that soon. Now let's take a look at some of the project settings inside the CS project file. When we open it up, there are a few different things that we first see. We've already looked at the target frameworks, but next we have some common application settings. We have some asset types such as images for the app icon, splash screen, and other assets. We have our project references that include the WebView.Maui package reference, which includes the Blazor WebView control, and there are a few other settings that are required for compilation. In .NET MAUI Blazor applications, there are a few files that participate in the startup process. The first one we'll take a look at is the startup.cs file. In this file, the two things to note for Blazor applications is the call to register Blazor MAUI WebView that lets .NET MAUI know about the Blazor WebView control and how to use it. And then there's the configure services method where we define services that are used throughout the application in both .NET MAUI pages and also in Blazor pages. The next files are the app.xaml and app.xaml.cs files that define the application entry point and application type for the entire project. And finally, we have the mainpage.xaml and mainpage.xaml.cs that define the main user interface for the application. Here we see this is the page that hosts the Blazor WebView control that contains all the Blazor part of the application. The user interface of a .NET MAUI Blazor application is divided into two parts. The first is the native UI that is defined using .NET MAUI controls in XAML or C#. That's what we saw in the mainpage.xaml file. The next part is the web UI that is defined using Razor files and the components within them. In a default project template, these are contained inside the Pages folder, where we have navigable pages such as the index page, the counter page, and the fetch data page, and some shared files that contain things such as the layout, menus, and additional components that are used throughout the application. Though most of the code in .NET MAUI Blazor applications is completely cross-platform, including the native and web UI, there's often a need to write platform-specific code to integrate better with each platform's unique capabilities. For example, in many platforms, you need to register a list of user permissions that your application requires or using a feature that is unique to one platform, such as accessing the Windows registry. This is done by placing a file in a platform-specific folder that is included only for that platform. Here in the main project, you can see there are Android, iOS, and Mac Catalyst subfolders that contain code and files for only those platforms. For example, in the Android folder, we have the Android manifest that contains a list of permissions required by this application, and you can change this list as your application requires. Now, let's say that on Windows, which is all the code is in the WinUI project, I want to read a registry key and show the version of Windows that it's running on. In the WinUI project, I can add a file into this Windows subfolder, which I've already done, and this has some code in it that calls some registry APIs that can only run on Windows. Now, I don't recommend you use the registry to read such things, but this is just an example of how I can write Windows-specific code. You can call any Windows-specific API or write Windows-specific code, such as using pinvoke, and get access to all of the platform's native APIs. Now, I've written this Windows-specific code, but how can I call it from a platform-independent way? Well, in the main project, I've written a little helper method called getWindowsVersion. Now, it's a little bit weird to have a Get Windows Version API that can run on Android, so how do I do that? Well, this class OS Version Helper is available on all platforms. This static method that I wrote is also available on all platforms. However, on line 13, I've added an ifdef for Windows, saying that if this code is being compiled for Windows, I want to call this new method that I wrote that reads the registry key. If it's running on any other platform, it always returns the string not Windows. Now that I have this platform-independent code, I can go into anywhere in my application. For example, I've changed the index.razor file to use my new helper method to show the current Windows version. If I run that, here we see that my application is loaded and it shows that the Windows version that I'm running on here is Windows 10 Enterprise. If you run this code on any other platform, this code won't even exist. It's always going to return the static string, not Windows. There are other ifdefs that you can use. For example, you might have an if for Android that would look like this. Android specific code. And you can close that out. Now you see that these are all grayed out because in the selector here you can choose for which platform do you want to write code. Now that we have iOS selected, it's not showing any of the Windows or Android code. It's all grayed out. In fact, we could even have completely invalid code here, and it's grayed out, and it's not a compiler error because we're not looking at Android, we're looking at iOS. If I switch over to Android, now the Android code lights up, and sure enough, we get a compiler error saying this isn't even valid. And lastly, when we switch to Windows, we see the Windows code is highlighted, and then the non-Windows code and the Android-specific code is all grayed out. A word of warning, be careful with how much code you have littered with all these ifdefs. This can make code a little bit harder to read, a little bit harder to maintain. I'm not saying don't do it, but be careful when you do. This was episode number 3 of EJL Instructs. Please let me know your thoughts and comments below, or if there's anything else you'd like me to cover. See you next time.